My name is Patterson. I'm the Chief Technology Officer for Asia Pacific and Japan. So I look after everywhere from India and Pakistan through to South Korea, Japan, of course Brunei, and all of the Asian emerging markets down to Australia and New Zealand. We're finding technology driving enormous change throughout many aspects of society that we've traditionally come to rely on. My role is to work with our Office of the CTO, who look at our sort of medium to long term, what we call Horizon 2 and Horizon 3 research and development. So we look at for technologies that are emerging on the horizon. We help to develop, standardize those, commoditize those, and bring them to market as products that you can take advantage of in terms of your businesses or constituencies. So my role is to work with customers such as yourselves to help you understand what's coming, so what's just across the horizon, to make sure that you can plan for how to incorporate those technologies into your businesses, but also to help reflect your needs back into the research and development organization. So to make sure that we're working on challenges and bringing solutions to market that help solve real problems in your world and for your customers. Other businesses, larger businesses and corporations, to be able to understand how to build those engines of innovation within their own organizations and to be able to respond within that. So what I wanted to talk to you about today was how we're seeing some transformations with emerging technologies coming into the marketplace over the next few years. Some of these are beginning to be adopted now, some of them are a little bit further away, but I wanted to talk to you about the impact that these are having and how we see technologies like banks and telecommunications, public sector being transformed and changed with some of these technologies. I'll then talk to you a little bit about how that's speeding up over this current kind of period of great change, and what sort of decisions you need to make and what sort of architectures you need to put in place in order to prepare you to be able to embrace some of these technologies and make full use of them. So here we have a couple of the technologies we're working on. First we want to talk about was the Internet of Things, or edge architectures, you might have heard us describe them. This has been occurring for a number of years. We've been driving sensors and intelligence into the world around us through the mobile phones that we carry, but also in devices that we embed in the everyday devices, in the everyday things, smart watches such as my own, or into production equipment, even down to video cameras that can track people, track processes, look for security and risk elements. We're seeing these starting to be used in the current environment with thermal visioning, starting to look for individuals who perhaps have a higher temperature, and we might want to check to make sure that they've been tested for disease and make sure that they're safe to come back to work. We're looking at integrating these with access control capability to ensure that companies have a safe to site initiative and can leverage some of that information into everything they do. Now, those sensors often are embedded right out into the edge of the network, and they're connected through these modern networks. To date, we've been using 4G or Wi-Fi networks. The next generation of those, 5G, is just starting to roll out now. And with the study that we did with IETF around the world in 2030, the 6G architecture will be becoming onto the market and around that kind of a time frame. These architectures are very different from the telecommunications architectures that we've come to know. Generally, they're working on what we call Open RAN, or Open Radio Area Networks, that run on a virtual network element. Those virtual network elements run in what we'd think of as standard servers. So the traditional proprietary approach to building telecommunications networks with radios and bespoke hardware infrastructure that's delivered into cellular poles around the environment and through our society can be shrunk right down into very small modules, and we will see many, many more of them as we deliver and roll out 5G. Those modules will be connected to fiber backhauls, which allow them to connect quickly back into our centralized kind of cloud core and cloud architectures, but they will also have some processing capability right down very close to the radio network. Because it's quite close to us, it will have very low latency and very high bandwidth. So we will have intelligent radio networks that will allow us to tune those networks to meet particular workloads. So for instance, an autonomous car or autonomous drone that might be relying on high definition video feed footage to look for issues or look for things that are coming up above. So for a drone, might be looking for a bird, for instance, to make sure it doesn't run into something. That video needs to be processed very, very close to the drone because it's needing to act upon that in real time. So that processing could be done in the device itself, in the car or in the drone, or in the 5G device that's very close to where the drone kind of currently is. The way that 5G networks are managed allows us to put those workloads that do that analysis out close to the devices in a containerized kind of format, or even right out to the device itself, putting policies in place across the network that we are leveraging to ensure that there's the low latency and high bandwidth required for those type of workloads. Conversely, for me to check my email while I'm on the road doesn't really require very high bandwidth or very low latency. Those sorts of workloads can be bumped down the list in terms of a priority and can be given whatever space is left over in the network once those critical kind of workloads have been balanced. So 5G gives us some new capabilities of driving down to the edge of the network where some of these devices are built. Now, the data that those devices are collecting and drawing back into the core and into our central infrastructure is being used in machine learning and deep learning algorithms to create artificial intelligence. Artificial intelligence is being built to create that automatic decision-making capability based on the data that we're generating. As I mentioned before, for drones flying into an environment to deliver a package, for instance, there's a bird flies across the path, it may need to make a very quick decision. Is this a bird that's going to damage the drone or to stop it from being delivered in some way? Is the bird likely to divert its path? Or is this the sort of bird that's not likely to, and I need to make some evasive maneuvers in order to be able to overcome this issue? So that requires the drone very quickly identifying what type of bird that is, predicting where that bird is going to be by the time the drone gets into that same physical position, and then making a decision based on what it wants to do to overcome that scenario. All of that is happening in real time, far beyond the capability of any human operator to be able to make decisions that are relevant in that space, and that really needs to be done by the machines themselves. So we're training these artificial intelligence algorithms to be able to work with us and to be able to develop that. We're also training them to do what we call neural language processing, where we're able to interpret and understand human language and be able to interact with us in much more natural ways. So traditionally we've taught ourselves how to type. I don't know if you're anything like me, but my typing is atrocious. And it's not a very natural way for humans to be able to input data and to interact with technology. So working with technology and a voice element gives us a much more natural way of engaging with that. So we will start to see more and more of those type of applications coming up that are driven by artificial intelligence. Now, blockchain and digital cryptocurrency is another one that's leveraging those networks to create a distributed network of trust. What we're meaning by that is that blockchain is an immutable and unalterable format that's distributed in many positions around the network. So a traditional transactional-based system would have had a single database sitting in a high-performance system that might be in a very secure data center, for instance. And any transactions that need to be processed need to be handed to that data center, processed, and the results of those handed back. What distributed blockchain architectures allow us to do is to have that blockchain stored at many points around the architecture, meaning that if one area goes down, many more copies of it are available to continue processing as and when we need to. The blockchain itself is inalterable and it's visible to all participants in the blockchain, which helps us to ensure transparency and make sure that fraud and other issues no longer become a problem. We're already using these types of networks for interbank transfers and for share markets, for instance, and we will see those expanded into many more use cases over the next kind of few years.